Welcome to my channel, everybody. Today, this is a class of I will do about differentiation. And now, what is the differentiation? In the language of physics, there's a about the velocity. And what is the velocity? In some instant, if a particle is traverse the distance like s1 s0 to s1, so the difference is at that instant s1 minus s0 and whole divided by del t. So this changes is called the velocity. Okay, this changes is called the velocity. Okay, so in graphical representation, see what is the meaning of derivative. See, this is the y-axis and this is the x-axis, and this is the curve, that is y equal to f of x. Okay, and at that instant the coordinate of that point P, that is x comma y, and there is a q. This is look like a big movement, but it is a small movement. I want to introduce a graphical representation, so that's why we draw this. Okay, and now if x comma y is this position of a particle, and then particle is moved to the q, in that position the coordinate of x here is x plus del x, and del x is very small, it is changed to 0, same as y we have y plus del y. So if we join the line PQ, and this is the chord of PQ, okay, therefore the equation of chord PQ is from coordinate geometry y minus y1, that is y, and this is equal to slope here and here x minus x1, and that is changes from this minus this, so y plus del y minus y and x plus del x minus x. So now y minus y is equal to del y by del x and x minus x1. Okay, this is the equation of chord. When, and now see here, when q tends to p, then so del x tends to 0 and also del y tends to 0, very small movement, so that's why del x tends to 0 but del y tends to 0, mathematically not equal to 0, okay, tends to 0. So the point q towards go to the point p, near about the point p. Okay, now that's why del x tends to 0 and del y tends to 0, and that respect, so we can say, and then PQ are form a tangent at P. Therefore, the equation, then this equation is from a tangent at P. Then the equation of tangent at P is, that is y minus y, and we can use here as a limit Lim, and del x tends to 0, and that is del y by del x and x minus x, and this is denoted by dy dx. This is denoted by dy dx. Okay, this is the mathematical notation, and this is the derivative of the function y with respect to x. And what is the meaning of that dy by dx in this curve? And this is the notation of dy by dx of y, and compare with the some straight line like y equal to mx plus c. If we compare these two lines, so we can say m equal to dy by dx, and you know, in this place if m multiplied to the variable of x, so m is called the slope of the line, So this is called the slope of the tangent. This is called the slope of the tangent. If we differentiate the curve at some point and some particular point, then we get a result, some result, and that result is called the slope of the tangent. Then this is the meaning of dy by dx. And now again we want to introduce a formula dy by dx, and that is equal to, see here, dy dx, and that is equal to, del x tends to 0, and that is equal to del y by del x. And now see, this is del x tends to 0, and we can represent as a y plus del y minus y, and also del x here. So again rewrite del x tends to 0 here, and y plus del y. See, y plus del y. If the point be y plus del y, so you have a given the function y equal to f of x. Okay, if we put here x plus del x, then value of y be y plus del y. Okay, the function is this. If we put the value of x plus del x, so then what will be the value of y plus del y. Okay, this is the comparison. Okay, so in place of y plus del y, you can write this figure. Okay, that is x plus del x, and y is here f of x, and by del x, and let del x as a h. So this is limit h tends to 0 here, and minus f of x plus h, and minus f of x by h, and this formula is called the first principle. Okay, this one is the first principle for derivative. Okay, this is the main important point, and this is called the first principle of the derivative. Okay, so use this formula, and this is the limit theorem. This is with the help of limit. This formula is called the first principle, but it is the use the help of limit here. Okay, and now the now the differentiation, there are some formula. We use this formula. Okay, now the next discussion here is the differentiation formula with the help of that. Okay, see carefully. Okay. So the first formula of this is ddx of x to the power n, and that is the formula is n into x to the power n minus 1. So with respect to x, and there is a x, okay, and n is a variable, n is a constant. When n is a constant and x is a variable, then the differentiation of x to the power n is n into x to the power n minus 1. So now we prove this formula from the first principle. So here dy by dx is equal to f dash x is equal to limit h tends to 0 f of x plus h minus f of x by h here. Okay, and for the function, you are given the function f of x is equal to, that is x to the power n. So you can write f of x plus h, and this is equal to x plus h whole to the power n here. Okay, and now limit h tends to 0, this is here x plus h whole to the power n minus x to the power n by h here. And again the formula here, you take a variable, let u equal to x plus h here. As h tends to 0, put here h tends to 0, then we get u tends to x here. So you apply this limit u tends to x here, and u tends to n minus x to the power n. Okay, this is n here, and h is means there u minus x. Okay, this is the formula of limit, and that we can write here n into x to the power n minus 1. This is the formula of limit theorem. Okay. So now number 2, for the function f of x is equal to sin x, sin mx. So ddx of sin mx is equal to m into cos mx. See, first we find f of x plus h, that is equal to sin m into within the bracket x plus h here, and again f dash x, that is limit h tends to 0, f of x plus h minus f of x by h here. See again, limit h tends to 0, and this is here sin mx mh minus sin mx by h. Okay, we apply the formula for trigo, that is sin c minus sin d, and this is 2 cos this plus this, so 2 mx mh by 2 here into sin of this minus this, that is mh by 2 here by h. Okay, now see, f dash x is equal to limit h tends to 0, this is here 2 cos 2 mx plus mh by 2 into limit h tends to 0 sin mh by 2 by h here, so we multiply here m by 2 into here m by 2. Okay, so now follow the limit, put the h as a 0, so 2 cos, this is here mx into this is here 1, so left here m by 2, so 2 are cancelled, so result here is m. Okay, this is the derivative of another formula, and that is the differentiation of cos mx. So we also introduce the other formula. See, here ddx of tan x, that is equal to sec square x. Same as sin x equal to tan x, therefore f of x plus h equal to tan x plus h here. So f dash x is equal to limit h tends to 0 tan x plus h minus tan x by h. Limit h tends to 0, sin by cos, and take a LCM, then we got here as a cos x plus h into cos x. Okay, then here sin x plus h into cos x, and this is sin x and cos x plus h, and this is equal to limit h tends to 0 h cos x plus h into cos x. Sin a cos b cos a sin b, and that is equal to sin x plus h minus x. X and x cancel. So this is limit h tends to 0 sin h by h. So that will be 1. And another limit h tends to 0 1 by cos x plus h into cos x. And this is equal to 1 into 1 by, if we put 0 then we get cos x into cos x, and that is sec square x. Okay, see the formula, and this is the, with the help of first principle we can show the formula of derivative. Okay, and now again you have a function given like f of x is equal to x cube plus 2x. So x plus h here, that is x plus h whole cube, 2 into x plus h here, and expand this as a x cube h cube 3x square h 3x h square, okay, 2x 2h, and f dash x is equal to limit h tends to 0. So see here f of x plus h minus f of x by h, limit h tends to 0, and this function is this x cube h cube 3x square h 3x h square 2x 2h minus f of x. This is your minus f of x, x cube minus twice x by h here. So 2x x cube and x cube are cancelled. Okay, plus minus. So limit h tends to 0, and take account h here. So and this is our h square 3x square 3xh plus 2 by h here. So h and h cancel. So see h tends to 0, h not equal to 0, so we can cancel the variable h here. Okay, now if we put the h tends to 0 to this equation, so we have let here 3x square, and this is 0 also plus 2. Okay, so this is the differentiation of x cube plus twice x. Okay, see, and the other here is f of x is equal to tan inverse x. Okay, see the function f of x plus h is equal to tan inverse x plus h. Now f dash x is limit h tends to 0, and this is a tan of x plus h minus tan x by h. We can use the inverse formula. Okay, then after do the follow the procedure. Otherwise we can take a variable like that, tan inverse x as a u, and tan inverse x plus h as a u plus k. Okay, as h tends to 0, if we put the h tends to 0, then uk tends to 0 also. So this is tan inverse x, and the value of in place of u we can put there the tan inverse x, so k tends to 0 here. Okay, and now this is here h tends to 0 and k tends to 0, both the tends to 0 we can apply here if h and x are both the exist here. Okay, if this is u plus k and this is u by h, so u are cancelled, so k are h both the exist here, so that's why we can write h tends to 0 and k tends to 0 both. Okay, now limit k tends to 0, so there is k, and find h here. So from that, so x plus h, and this is equal to tan of x plus h. Okay, so h is equal to tan of x plus h minus x, and x means tan u. So substitute here tan of u plus k minus tan u, and write the formula cos by sine by cos sine by cos, and then limit k tends to 0 and take LCM. So that is k into cos of x plus k and cos u, sine of u plus k and cos u, and cos of u plus k and sine u. This is equal to limit and k cos x plus k. So this is u here and cos u. So this is here u plus k minus u. So u are cancelled. So k by sin k is equal to 1. So from the limit k tends to 0, this is sin k by k, and this is k here, not needed to write there. Okay, this is here k and by k. Okay, k are cancelled. So limit and limit of both are separated. This is k tends to 0 and cos of 2 plus k and cos u, that is equal to cos square u, and cos square u means that is equal to 1 by sec square u. Sec square means 1 by tan square u. Tan square u means 1 by 1 plus x square tan u. Okay, so this is the differentiation formula of tan inverse x, that is 1 by 1 plus x square. Okay, this is the small discussion about the differentiation, and with the help of first principle is this. So see carefully. In the next video there are the most problem about the differentiation, an important problem we shall discuss in the next video. Okay, bye.